Hi everyone, welcome to ANR Academy. Today we are going to discuss how to find third vertex of an equilateral triangle when two of its vertices are given. See here, with the help of complex numbers, suppose B and C are given, then to find the coordinates of A, this is the short technique. A written as either minus b omega minus c omega square or minus b omega square minus c omega, where omega and omega square they are minus 1 by 2 root 3 by 2, minus 1 by 2 minus root 3 by 2, real and imaginary parts. Yes, there are two possibilities. Let us see this figure. There is an example. If B and C are given in an equilateral triangle, then here the aim is to find third vertex. If B and C are given in an equilateral triangle, then the third vertex possibilities, maybe one of the third vertex lies above the given BC or below the BC. There is a line segment BC for which in the upward direction there exists a third vertex, or maybe in the downward direction there exists another vertex. Due to that reason, there are two results. One is, remember, minus b omega minus c omega square or minus b omega square minus c omega. After completing this example problem, then we will discuss the proof. See, I am going to write vertex A. A written as minus b omega minus c omega square, or you can write first start with omega square and then end with omega. These are the two possibilities. Therefore, A written as minus b, b written as 0 plus 2i in complex form. Simply it is 2 times of I. Next omega, omega is minus 1 by 2 plus root 3 by 2 into I. Next minus sign. C, C is 4 plus 0i, that is just 4 we get, multiple omega square written as minus of minus root 3 by 2 into I. Now by solving this we get third vertex. Let us see here. A now written as minus into minus plus sign, 2i multiplied by 1 by 2 gives just I, and after that 2 gets cancelled. Minus root 3 I square value minus 1, so that what we get, plus root 3. Minus 4 into minus half, that is plus 2, minus into minus plus sign, 2 root 3 I it is. Therefore, A written as 2 plus root 3, next 1 plus 2 root 3 of I. This is in complex form. Therefore, vertex A written as x coordinate 2 plus root 3 and y coordinate 1 plus 2 root 3. In the same way, with the help of A equal to minus b omega square minus c omega, we can find another vertex also. Just remember that in the second case you will get negative sign here. Here you got 2 plus root 3. In the second result you will get 2 minus root 3, conjugate value. Here 1 plus 2 root 3 you have, you will get 1 minus 2 root 3. Let us see. From this A equal to minus b, that is minus of 2i, omega square written as minus of minus root 3 by 2 I. Next C, that is just 4, omega minus of plus root 3 by 2 of I. If you simplify this, 2 gets cancelled, minus I into minus 1, that is plus I, minus into minus plus sign, 2 gets cancelled. Next, root 3 into I square value minus 1, so that minus root 3 we get. Yes, here the difference. Here you have plus sign, there you will get minus sign. Minus 4 into minus of, that is plus 2, minus into plus, minus 2 root 3 I it is. Therefore, A written as, first real part I am going to write 2 minus root 3, next imaginary part 1 minus 2 root 3 of I. Therefore, coordinates of A written as 2 minus root 3 comma 1 minus 2 root 3. So, this is the short technique to find third vertex of an equilateral triangle when two of its vertices are given. Let us see the proof. Suppose that in organ plane Z1, Z2, Z3, these are three vertices, and there are three vertices of an equilateral triangle. All the three sides are equal in length, and here the angle is clearly 60 degrees. Vertical angle 60 degrees. I am going to extend this. Here the external angle is 120 degrees. If I write this in vector form, this is the vector written as, this vector written as Z2 minus Z1, and another vector, this is Z3 minus Z1. Z2 minus Z1, Z3 minus Z1 are two vectors, and angle between these two is clearly 60 degrees. Yes, Z2 minus Z1, AB vector written as OB minus OA, in this form it is, so that it is clearly in this direction, Z1 to Z2 written as OZ2 minus OZ1. Next, and it is in this direction, and here the angle is 60 degrees. If I change the direction, that is, if I write Z1 minus Z2, then the angle made by Z1 minus Z2 with Z3 minus Z1. Z1 minus Z2 means reverse direction. So, in the reverse direction, now the angle between them is 120 degrees. Okay? Yes. By rotation theorem, I am going to use Coney method. Rotation theorem, Coney method or rotation theorem. From that, you can write final unit vector equal to initial unit vector multiplied by e power I theta. So, here I can write unit vector. Suppose the angle of rotation in this direction, in the anti-clockwise sense, then this is known as Z1 minus Z2. Final wala Z1 minus Z2 unit vector you have to write, divide by modulus Z1 minus Z2 equal to initial unit vector. Initially you have Z3 minus Z1. Z3 minus Z1 divided by modulus Z3 minus Z1 e power I theta theta value here 120 degrees. And here, since it is an equilateral triangle, these are of equal length, so they get cancelled. In Cartesian system, Z1 is A, Z2 is B, Z3 is C, Z1 is A, and e power I theta written as cos theta plus I sin theta, so that it is cos 120 degrees plus I sin 120 degrees. If the direction is reverse, then you will get there minus angle, so minus 120. That gives the second result. Now in the anti-clockwise sense 120, you may calculate clockwise also. In that case you have to write minus 120 degrees. Just first result we are going to prove. Now A minus B equal to C minus A multiplied by cos 120 degrees value. In the second quadrant, cos value negative and cos 120 degrees value cos 180 minus 60 gives the result minus half. Next plus I sin 120 degrees value. You can write 120 degrees as 180 minus 60, so that what we get I root 3 by 2. Now you can write A minus B equal to C minus A of, this is clearly omega. Now A minus B equal to C omega minus A omega, and also you can write A plus A omega equal to B plus C omega. If you take A common, you will get 1 plus omega inside, and here it is B plus C omega. 1 plus omega written as minus omega square. Why? Because 1 plus omega square value equal to 0. So that I can write here A into minus omega square, that is equal to B plus C omega. Now if you multiply with minus omega on both the sides, what happens? Observe. This is B into minus omega and this is C omega into minus omega, and this is clearly minus into minus plus sign. Omega square into omega, that is omega cube value 1, and hence left hand side only we get A. And in the right part what we get? Observe, this is minus B omega minus C omega square, and hence the result is proved. Therefore capital A we got minus B omega minus C omega square. If the direction is in the clockwise, then you will get minus 120 degrees here. Automatically in place of omega we get omega square, and that gives the second result, that is this one. A become minus B omega square minus C omega. So this is the short technique to find third vertex of an equilateral triangle when two of its vertices are given, and this is the proof. You can find another result by writing here the angle minus 120 degrees. I hope you understood everything. The students, those who are watching my videos, please subscribe the channel and don't forget to share, like and comment. Thank you so much.